So we're going to start the last unit in Algebra 1 before EOC, last unit before EOC. So what we're going to be doing is going to Topic 11, Lesson 1. You should have a practice packet in front of you. The assignment is going to be the practice in Schoology over 11.1. And you are going to need a calculator for today, so make sure you're ready for that and prepared. So the first thing we're going to do is we're going to, not sure what that's about, we're going to talk about mean, median, and mode. So this is hopefully a review for you, but I just want to make sure that it is. So when we're talking about mean, remember that's also called the average. Okay, so that's also called the average. Average. Wow, that's bad handwriting. Anyway, and remember to find the average first. Add all data, so add each piece. Second then is that you divide by the number of data. Okay. So for instance, if I'm doing these numbers here, 25, 24, 29, 22, 25, 27, 28. First thing I'm going to do is I'm going to add those all up using my calculator. And I got 180. And then you divide by 1, 2, 3, 4, 5, 6, 7. You divide by 7. And you get 25.714, blah, 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 blah. So your average is approximately 25.7, we'll say. Okay, so that's how I find the average. Now I'm going to find the median. The median is the middle number. And the way you can remember this is if you're driving down a highway, there might be a concrete or sometimes grass between your lane and the lane of the other. That's the median. That's the middle of the road. This is the middle number. So it's the middle number. And these are all called central tendencies. These are called central tendencies. And they usually are in statistics units. So that's where this is all coming from. The median, the way you find that is first, you're going to put write all the numbers in order. Oops. So first, write the numbers in order from smallest to largest, okay, or largest to small. It doesn't matter. Small to the large, large to small. Okay, and then you're going to find the middle number. So you're going to count to find middle number. And I'll show you what I mean by that as much as I can. Count to find middle number. Okay. Now if it's an even number of data, then you're going to find the two middle numbers and you're going to add them together and divide by 2. So you're going to find the average of the two numbers. So if it's an odd number, you just count to the middle. If it's an even number, then you have to take the two middle numbers and divide by 2 to find the median. Okay, and if you have questions, just ask me. This is stuff that could possibly show up on the EOC, but also stuff you should just know. So if you're absent and watching this, just ask me and I can make up another example sometime. Okay, so if I'm doing the particular one that we're here, I'm going to first write these in order from smallest to largest. So I have 22. And I'm just going to do a single line through them so I can come back to them if I needed to. 24. And I actually would probably just put an underline underneath it. I have a 25. I have another 25. I have a 27. I have a 28. And I have a 29. Okay? Now in order to find the small and then the middle number, this is the only disadvantage about this, is that I would look at, okay, these two kind of like knock each other out. And these two knock each other out. And these two knock each other out. So where's my middle number? Right here. So I just kind of count in towards the center. It's kind of like what we did when we were finding the axis of symmetry. We would start at the x-intercepts and we would count in until we'd find that middle spot. That's how you find the median also. Now, if we had an even number of data, would take the two middle. Let's say that we had an even number, would take the two middle. Well, that's not a good example. But we would take the two middle ones and we would add them together and divide by 2. Mode is the easiest one because it occurs most often. Occurs most often. And how I remember it is mode has an O in it, often has an O in it. Okay, so what's the mode here? The mode is the one that occurs most often. That'd be a 25. And you can see a lot of times your central tendencies are they're not gonna usually be this close. So this is just one that I picked. So not a big deal. Now to find the range, I take the big number minus the smallest number. So after I find the median, for the mean, the mode, and the range, it's easiest if I put my numbers in order from smallest to largest or largest to smallest. So to find my range, I'm going to take 29 minus 22, so my range is 7. Now this range here is different than domain and range. Domain and range is something else. Okay, there are slight connections, but just remember the range is, what are the range of values? That's all range is talking about. So that was a review. Now we're going to go into topic 11, lesson 1, and we're going to talk about different displays of data. So this is in your packet also, manual, okay, that person, we're going to call him Manny, plans to buy a new car with the gas mileage shown. To determine if the gas mileage of his car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the other cars he has researched? Manuel wants to compare individual values, so a dot plot. We're going to do a dot plot. A dot plot is a good way to show that information, and we're going to talk about these. So we're going to create a dot plot of data by first drawing a number line that represents the range. So there we go, the range of the data. Plot each value from the table as a plot above the number line. Okay, and then it says clusters and outliers, and we're going to come back to that. So we're going to now do a dot plot. It's just a number line. What is our smallest number? Looks like it's 25. Okay, and then we're going to try to represent each number as we go up. Now we can actually make our dot. I'm going to erase that number and make my line a little bit longer so that we can kind of see it. I'm going to actually erase that whole line. And I'm going to put it down here at the bottom and dismiss that. So I'm going to start down here. I'm going to make a whole long line. And you can start at whatever number we want. Our lowest one, though, is 25. So I'm going to 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. You know how to count. I don't need to count for you. My highest value, 45. Wow, I'm just going to make it. I'm not going to make it. Okay, I'll be right back. Okay, so I've put some numbers on here. And with a dot plot, you don't actually kind of indicate where the number is. It's just loose like that. So then you actually just put a dot right above where that number is. So I have a 25, so I put a dot. I have a 45, I put a dot. Okay, 26, I put a dot. 35, I put a dot. Okay, and these are the gas mileages of different cars. And you're going to put the dot above those, and I'm going to put those in different colors. $31, $26. I have another 26. Okay, 30. So we're just putting dots on here for each of those numbers. 29, 26 gets another dot, 28. Wait, now I lost track. 1, 2, 3, 4 26s. So another 26, 27, 27, 28, 28. Now, the one thing I did wrong is that you do try to kind of line your dots up so that then you can easily count that there are 4 of, like for 26 and 28 there are 4. So we created a dot plot of the data by first drawing the number line and then representing the range of numbers. So one of the things that I want to talk about is clusters and outliers. So let's start with outliers. Outliers means that they are outside where the norm are on. And see how the clusters, so if I were looking at clusters right here, this is kind of where my data is clustering, is right through here. My gosh, I can't change the color. Clustering right through here. And even more so right around here. That's where you're clustering. Okay? So that's a cluster. It's kind of like that's all together. The outliers, and we'll talk about outliers both for this one and also for other ones, but your outliers are the ones that are further out. So right here, that is an outlier. Okay, that one's an outlier. This one's almost an outlier. It's kind of an outlier, so this is kind of an outlier. It depends on how picky you want to be. Okay, but everything else is kind of clustered. See how this is all kind of clustered right through here. Okay, so then what we do if we want to answer that question, so if we want to, and so what he wants to know, to compare the individual values. He's trying to, so go back to the original, he's going to gather information. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the others? So his car is a 26. So if you look at that, sorry, so sorry. Okay, so if you look at what his car is doing, his car is 26, and if you look at what was happening, it's kind of right along with everything else. So his is right along with many of the other cars. It occurs very often that they have a miles per gallon of 26. But this is an example of a dot plot. A dot plot, you'll learn, is if I have individual values, I might want to use this. The next one we're going to be looking at, okay, is we're looking at a marketing team is about to launch a campaign for a new product that is targeted at adults aged 25 to 34. The team is researching the age range of viewers of a certain TV show to decide whether to advertise during the show. The data show the ages of random samples of 30 viewers, okay, of 30 viewers of the show based on the findings. Should the marketing team launch their campaign during this particular show? So we're going to eventually do that, but first what we're going to do is that we are going to make what's called a frequency table. This right here is called a frequency table, hence the name. And this is done in ranges because what we're going to eventually draw is what's called the histogram. Okay, we're going to eventually draw a histogram on this chart right here. Okay, but in order to do that, we need to find the frequencies. A histogram is always with ranges. A histogram looks like a bar chart, but a bar chart just goes for individual numbers, and a histogram will be ranges of numbers, and they will touch. Okay, they have to actually be touching. So let's go through and put our data in, and we're just going to put tick marks. So we go 14, 21, and I'm just putting a tick mark of where it belongs. 22, 17, 24, 20, 26, 15. Okay, so let's do those tick marks in there. Remember when you get to 5, okay, you're going to draw a line across it. Okay, let's go. So you made a frequency table of what is happening with all of the data that is in the table. Now you can always check yourself. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 by 2. I should have 30 pieces of data. So there's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I have 30 pieces of data. And now what we're going to do is we're going to actually put them where they are frequent. What is the frequency? So 10 to 14, that's the first one I'm looking at. 10 to 14, okay, there are 3 pieces of that data. So I'm going to make a line right here for that interval, okay, and usually you color it in. Now I'm going to look at my 15 through 19. I have 9 of those, so 9 would be located about right here between the 8 and the 10, and your bars will touch, okay, and they just kind of go over that, and then you color them in, okay. So a histogram, the bars touch. Oops. And your lines are probably a little straighter than mine. But the bars do touch. In a bar graph, they do not, and a bar graph is just a single number, whereas a histogram, notice it's an interval. So that is the difference. So now we're just going to finish this. 20 to 24 is 10. So I come up here to 10, and I draw my little graph, my little bar right there. Okay. Yours are, again, your graphs, your bars probably look a little better, so you color all that in. Okay. For those of you who are really good at coloring, you're going to actually color in every single part. Okay. And it might be helpful if we actually outlined it in black and then colored it so we could see each little bar and then colored it in red. Okay, so 25 to 29 is 4, so that's going to be a little bar right there. I'll go back and color in just a second. And 30 to 34 was 3, so about right there. And then 35 to 39 was 1, so it'd be about right there. Now I'm just going to go back and color all those in. Okay. Okay. And for those of you who are perfectionists, feel free to color those in a little better than what I did. Now, we've made our frequency chart, we've made our histogram, and it says, should the marketing team? So the question is, the data shows the ages of random samples of 30 viewers, and so these were all their ages. Based on the findings, should the marketing team launch their campaign during this particular show? And this show that we're talking about was targeted for people that were 25 to 34. So we look at 25, let me go in a different color. We went from 25 to 34. Should it be during that time? No. If I'm going to target a show to that, I want to go at a different time, because right now, look, your biggest ones are your intervals go from 15 to 24. So this is not when they want to do it, so this would be a no. And as you can see, if I'm looking at this, these numbers right here, oops, if I look at what we're trying to target our audience of, there's only 8. I can't count. That's 7. So that's 7 out of the 30 people. So that's only about 20, it's 23%. That's only about 25% of your group is watching between those. Your age is watching that show. So this is not when you want to target that audience. Now here is a beautiful histogram of what we just created, but we need to know how to draw them. So, but the other thing is we need to be able to understand and interpret the data. So again, the same information, 30 viewers, what age group would be a good match for the products? And you would say from 15 to 24. So from 15 to 24, the ages of 15 to 24. And the reason is because, now according to this, oh, this must be a different table than what we had, because they had 10. Okay, so the frequency is 10 for 15 through 19 and 10 for 24 through 34. So the reason is because you have more people in that age range that you're trying to target. Okay, good. Now the next kind of data display we're going to be talking about is what's called a box plot. Now a box plot shows the now a box plot is sometimes called a box and whisker plot, and I'll show you why when we create one. And it is shows it, and you should have these all in your notes. Write those down, first and third quartile. So you're just filling in. A box plot shows the distribution of data using a 5-number summary. What are those 5 numbers? The minimum, the maximum, the median, the first quartile, and the third quartile. So the minimum is just the least value in the set. The max is the greatest value in the set. The median is the middle number, what we were just talking about before. What is the middle number when they're arranged from least to greatest? And then the first quartile is the middle number in the between the minimum value and the median. So it's the first quartile. Think of it as a basketball game. The first quarter ends halfway in the first half. So if between when I start the game and the halftime, okay, halftime is like the median, that's the middle number, it's halftime. And so your first quartile would be when the first quarter ends. It's halfway from the beginning of the game to the halftime of the game. Okay, the third quartile is halfway between the halftime of the game and the end of the game. Okay, so it all kind of makes sense. So if you need to pause this, make sure you have those definitions written down, because we're now going to make a box plot. Students at a local high school organized a fundraiser for charity. Caitlin, the student council president, announces that more than half the students raised over $50. The amounts of money raised by a random sample of 24 students is shown. Do the data support Caitlin's claim? Okay, so we're gonna look at the data from least to greatest to identify each of the values. We're gonna find the median, the minimum, the maximum, and the first and the third quartile. We're also going to, and I should have added this in, I'm going to go back for just a second, if I can, and talk about the interquartile range. Interquartile range. The interquartile range is the range, so remember when we talked about range, of numbers from the third quartile to the first quartile. And the interquartile range, the other reason that is important is because that is where 50% of the data is. So it represents the range of the mid 50%. Okay, so it represents the middle 50% of the data. So when they talk about what is the middle 50%, they're talking about the interquartile range. It's called the interquartile range, so IQR. So what we're going to do now, and you don't need to watch me do it, is we're going to take this data in this box right here, okay, this whole box that is given to you, and we're going to write the order in order from smallest to largest, and we're going to do that right now. Go. And you're going to write it right up here, okay? So, because we're going to make a box plot down below, so just kind of write it right up here. So I'm going to start off with 25, which is my smallest number. Okay, go. And I'm just going to indicate when I've used that number by drawing a line underneath it so that I can kind of make sure that I cover all of it. 25 is my lowest. Oh, there's another 25. Okay, and then I have a 26. You got the idea now. And as you can see, I ran out of room, so I actually had to go back to rewriting it down in blue. So I'm going to rewrite that, so you don't need to watch me do that. So the tactic I use is I go through and I see, did I use all of my 40s? I did. So now I'm at 50. I don't know why my computer is freaking out like this, so I apologize. Yeah, and it does take some time, as you can see, to write all this out and get it all collected. And so yeah, it's kind of a pain. But that is kind of statistics. Now there are programs that do all this, and I'm still not going to be able to write it all. Okay, I'll be right back. And then you want to double check to see if you actually got them all. So I have 1, 2, 3, 4, 5, 6, 7, 8 times 3, there's 24. So count them. 1, 2, 24, and I forgot one, so let me find it. Okay, so we've organized them from least to greatest. We have the exact sum. We're going to find the median. So here we go. Use your fingers. So what you can't see is I'm pointing to this one and this one at the same time. And then I'm pointing to this one and this one at the same time till I find the middle. Go. So you would have found that your two middle numbers are 45 and 45. So that's going to be where your median is. Now you add those together and divide by 2, so your median is 45. So this is your median right here. This is your median. Okay, is 45. Then you have to find the median. You have to find the first quartile. The first quartile, you're going to go through and you're going to find the middle there. So I'm pointing to that one and this one and this one and this one. Okay, so I'm finding that middle number in between these two. Okay, and again, it's going to be between my two middle ones. So this won't always happen, but I had to have an even number of data. So my first quartile is going to be right here. So this is my median. This is my first quartile. Now I'm going to do the same thing on this back side. I'm going to match them up. So this one and this one, this one and this one, this one and that one. Find that middle number is what you're going for. Okay? So these are my two middle numbers, 50 and 54. I'm going to go halfway in between them. So I'm going to add 50 plus 54. I'm going to divide that by 2, or you can just look at it and go, what's halfway in between? It's going to be 52. So 52 is your third quartile. Okay, so now we're going to draw a box and whisker plot. So now you're going to draw a number line, and you're going to go from, you're going to just go up by tens, is basically what you're going to go. So you're going to go from like 10, 20, 30, okay, and we're going to mark it in between. So make your line right here, and it's going to start off and go 10, 20, well, go about halfway in between where you're at. So here's about 50. Nope, that's not what I want. So you're going to make every line about every 2 marks. So just go ahead and make marks. We'll eventually get up to 70. Okay, so I'm going to go 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 33, 4, 36, 38, 40, 42, 44, 46, 48, 50. Okay, you get the idea. Okay, this is not my best work. This is not what I'm as strong at, obviously. So you're going to indicate the minimum with a dot and the maximum with a dot, and that's going to be where your whiskers are. So my minimum is 25, so 2, 4, so about right here. There's my minimum, that's my lowest point. My largest point is 68, so that's going to be right here. And those are going to be where it ends. My median is 45, so 42, 44, 45. So I draw a line there. Now I'm going to draw the box. And it's going to consist of the first quartile, the median, and the third quartile. So I'm going to go 32. That's going to be where my box begins. My box is going to end at 52. Okay. And my whiskers go from my minimum to my box. And my median is always right here in the, it's not in the middle of the box. It usually isn't. It's going to skew one way or the other. It means it's going to be towards one end or the other. So this is my first quartile. This is my third quartile. This is my median. And you can see this right here, from here to here, from 32 to 52 is going to be your, where your box is. That's your middle 50% of your data. Okay? And then everything else is just kind of gone out here. Now, when you look at a box and whisker plot, you can see that that doesn't actually show individual data at all. Okay? So this is a box and whisker, and we'll practice some more of those in class. So suppose Caitlin wants to make the statement that 25% of the 24 students she sampled raised over a certain amount of the charity. What is that amount? So when we're looking at 25%, we're going to have to go back to our box and whisker. Since this is our middle, our interquartile range does the middle 50%. Here is 25%. Here is 25%. And then that's 75% is over here. So if I looked at what is the 25%, that would be $32. So 25% of the people raised $32. Okay, up to that. What is that amount? And it was $32. Okay, because the third quartile is 52, so 75% of that raised $52. 25% is greater than 52. So what is that amount? The 24 students. Okay, so you get the idea. Helena's dance team scores 68 points at a competition. The scores for all the teams that competed are shown. Helena wants to know what place her team finished. Should Helena use a dot plot, histogram, box plot to display the data? So what this does is it says a dot plot is if you want to look at each individual value. A histogram is if you want to look at a range or intervals. And a box plot is if you want to look at the center and spread. And a lot of times that's going to be a summarization of what's happening. That's going to be about your percentages. So if she wants to know what her team placed, should she do a dot plot, a histogram? What would be the best one? And I think it would be the dot plot, because we want to look at what each team does and what the percentage is. Okay, so she would use a dot plot in order to figure out what it was. Then we could actually construct one and find out where your team finished. So you could create and analyze a dot plot. So you could make that dot plot and figure out where those are. If you want to see that, go to the interactive book or talk to me some more. So then it says, okay, let's go and do that again. What if we not want to know the percent? If we want to know the percent, that's when we're going to use what they call a box plot, what I call a box and whisker plot. Okay? But they call the box plot. They both mean the same thing. This is just a summary of everything that we've talked about, and that is on your paper. And then I just want to point out a couple more things. It says error analysis. Taylor says you can determine the mean of a data set from a box plot. Remember, the mean is just the average. The only thing you can determine from a box plot is the median. Okay, so that's all you can determine. So you can determine the median. The other one they had is, can you determine the minimum and maximum values of a data set simply by looking at a dot plot? No. Histogram. Oh, minimum and maximum? Sure you can. Histogram? No. But then a box plot, yes. So you can for a dot plot and a box plot. And that's, no, you cannot for a histogram since individual values are not displayed in each one. You can in a box plot because those whiskers are your minimum and maximum. So we have now covered everything. If you have more questions, please ask us. You're going to now do the practice for 11.1, and then if you have more questions after you do the homework, please ask, and you know where to find us. Thank you.